Good morning, afternoon, evening, wherever you happen to be, whatever time zone it happens to be for you. Thank you very much for attending, and hopefully I can entertain you and inform you for the next hour or so. As I said, I'm Kyler Abernathy. I'm currently Director of Operations at the Exploration Technology Lab at National Geographic. Our sort of team's overall mission is to create and use technologies to support the mission of geographic explorers, and those can be researchers, explorers, storytellers, excuse me, and educators. So we provide a variety of technological support to all the geographic explorers working in different fields with different aims. Sometimes it's just as simple as advice, and other times it is creating bespoke, unique technologies. And one of those technologies that we have created over the years and has become an ongoing program is our Crittercam systems. That's our brand name for what more generically we refer to as animal-borne imaging. So I will jump into my presentation here. Sorry, we'll make the transition. Hopefully make it. It's going to be a slight technical hiccup with, for whatever reason, my little strip at the bottom of the screen is not going away like it normally does, but it's not going to hide anything terribly important, so we'll just live with that. Oops. And I am back at the beginning. So there's our pretty little logo we had made actually for this some years ago. So again, sort of what Crittercam is. Again, it's generically we call it animal-borne imaging. That's hopefully self-explanatory. It's an animal, a camera carried by an animal, and these are for wild animal research. And it is similar to instrumentation that other people put or attach various things to animals. It is not, as this photograph from the magazine cover implies, just handing one to an animal, or in this case, where an animal chose on its own to carry around a camera. Why would you want to put a camera on an animal? There's a lot of cases where there's things you can't see about an animal's behavior. It's in a place where a human can't go, potentially deep in the ocean, or where being close enough to observe would potentially affect the behaviors you're wanting to observe. Now, the genesis of this idea with biologist Greg Marshall was very focused on marine animals. He was a marine biologist, and in a lot of ways, observing animals in the ocean observing directly is harder than doing it particularly on a land animal. You just can't see, specifically on land, you have the potential to potentially use binoculars or something like that and look at an animal from quite a distance. Usually not viable in the ocean. You just can't generally see that far. No matter how clear the water is, you're usually limited in your range. And particularly underwater, if you are close enough to see the animal, they almost definitely know you're there. But we would argue that even on land, there are cases where the visibility is that limited, whether it's vegetation or other features that prohibit you from watching the animal. And there's just also being able to, as the animal moves around, being able to be continuously observing an animal as they move around without losing sight or, again, affecting the behavior. So if you think about, sort of biology, natural history started with people going out there and watching the animals and writing down notes on behavior, what went on. And I think that still is very powerful. But as you can see, just sort of an example of this, obviously those elephants know the researchers there. In this case, they don't seem to be particularly bothered by it. But even if the animal's not disturbed by the human presence, there might be an influence there. They might change their behavior in ways that might not be obvious. So there's always that potential for a human being close to the animal, observing that behavior, affecting the natural behaviors you're trying to study, at which point you're not getting sort of real natural behavior data. Now, trying to combat that, partly that influence in the human presence and the issue of collecting data on animal behavior over extended periods where a human just can't physically follow along for extended periods or in difficult environments. The rise of what's generally referred to as biologging, putting instruments on the animal that are recording various behaviors. And it can record over months or a year or more, potentially, recording different kinds of sensor data, movement, light levels, GPS tracks, temperature, depth, provides us insights into the animal's lives over extended periods and in these difficult environments, and hopefully without the disturbing presence of a human observer. And you get, records like this, I'd say a dive recorder on a marine animal diving, you get depth over time, get you some ideas of what they're doing, or, GPS or other satellite-based tracking gives you the animal's movements over time. And this is all really incredibly valuable data that's, really the advent of this kind of technology has really allowed us to advance in understanding animal behavior and ecology. But there are limits to what you can get with that kind of data. And so bringing cameras into this has the potential for a couple different things. I mean, it can be pure discovery. We just don't know what the animals do. Let's see what goes on. And this example of a project working with leatherback sea turtles off Costa Rica was an example of this, where we were hoping to learn about foraging behavior and habitat use. And what we found was actually mating attempts in a place where the current understanding at the time was that mating activity did not occur near the nesting beaches, that the males didn't migrate to the areas where these females migrated to lay their eggs. What we discovered repeatedly was males hanging out off the beaches and very, very insistently making attempts to mate with females. And this was kind of an example of discovery where the researchers didn't know to ask the questions about mating behavior just off these nesting beaches because it wasn't known to happen. Unlike other sea turtles, where mating is known to happen off the nesting beaches or near the nesting beaches, all this activity, happened well below the surface. So it wasn't something easy to observe from the surface, and the visibility in the water was not that great here either. So someone out on a boat might see leatherback surfacing to breathe, but may not be able to observe this mating activity that is, other times is observed in clear waters where activity happens near the surface with other species. So again, it's one of those examples where researchers didn't even know to ask that question in this circumstance. So putting a camera on the animal revealed some important behaviors and activities going on that no one even knew was happening at that time and place. And this is, could be true. This is an example of we worked with researchers from the University of Georgia, working with domestic cats that were let out to roam. And we collected, I think, over 1,000 hours of video over about a year on this study. And so we discovered things about people's pet cats that they didn't know, nobody even knew. This is a case of this cat hunting. There's quite a fair bit of hunting, but not every cat did hunt. That was one thing we discovered. There does seem to be some differences in individual cat behavior. We discovered a lot of interactions between cats that not of the same family. There were interactions potentially with cats and wild animals, in this case a very pregnant possum. So again, even domestic pets, there are aspects of their lives that we and no one really knew about that are revealed through the cameras. The images just have a lot of information. There's the old chestnut about a picture's worth 1,000 words. Well, video is 30 pictures per second. So we say we're collecting about 30,000 words of information per second, per second. Excuse me. So that's a lot of information is sort of extractable from the images. Another important thing that we think that the animal-borne images can do is they actually can work as a verification tool. All these other tools, the depth recorders, the satellite tracking devices, motion sensors, I will say that those kind of devices, animal-borne imaging tools, will probably always be bigger, heavier, more expensive, more complicated to use than a lot of the other kinds of remote sensing technologies that are out there. But one thing Crittercam can do, or other animal-borne imaging can do, is help verify what researchers think they're learning from that behavior. We can add to it, or again, provide verification for interpretation. This is an example. We're working with water bucks at Ngorongosa National Park in Mozambique. The researchers that we were working with were using DNA analysis from fecal samples to study what the water bucks are eating. And they had genetic barcodes for various kinds of plants. But they did discover, when they compared what they were seeing the animals eat from the video samples to what they were getting out of the fecal DNA analysis, that there was a significant discrepancy, particularly regarding one plant. And so they went back and were looking at the DNA analysis process, and they discovered that the barcode section of DNA that they'd used to identify this particular plant seemed to be getting broken up in digestion more than the sequences for other plants. And so they were not getting as high a signal for that particular plant as they were for other plants. It wasn't, their DNA sample was not, or the analysis wasn't truly representative how many or how much that the animals ate that particular plant. And sort of seeing the direct evidence of what the animals were selecting to eat in the video sort of flagged that for them, and they basically were able to modify their analysis, realizing that genetic analysis tool was not giving a true picture. And so that's one thing that we've discovered, and we believe that is very powerful use of the animal-borne imaging, is all these other instruments, these ISIS, in case like fatty acid, stable isotope analysis, DNA analysis, dive recorders, motion detectors, satellite tracking. All these tend to be we refer to as indirect measures of very complex behaviors. Again, you're not actually seeing the behavior. You have a different data stream, and then you're interpreting behavior based on that data stream. But it is interpretation and extrapolation. And so these animal-borne imaging tools can provide sort of a ground truthing of what you think you're getting from that other data. And very powerfully, that can make that other kind of data more powerful, because you have sort of a ground truthing of your interpretation. You have a stronger basis to say that's what this data means, these other data streams mean. And we have evidence that our analysis or interpretation of it is valid. And so it creates a greater basis for sort of, I think, justifying collecting that kind of data. You can actually go, maybe potentially you could go backwards. You have data sets, past data sets. You can sort of reevaluate them based on this sort of confirmation or correction based on the video interpretation. And like I said before, the animal-borne imaging systems are challenging to use. They are larger, more expensive, more challenging to use than a lot of these other devices. So you have the potential to go forwards with using these other devices with a stronger basis, justification for doing it, and knowing that you have a better interpretation. You may not ever be able to put out as many animal-borne camera systems as you could sort of motion sensors, which are small and cheap and low impact and last a long time. But you can do so with a greater confidence that you are in what that other data is telling you. Again, so at the core of it, in a way, the technology of an animal-borne camera system is fairly simple. There's a small camera. There's a little controller that allows us to program the device to turn on and off at particular times, to when you should be sampling the video, the battery that powers it, and some kind of enclosure that protects it from the elements, whether that is in the ocean or on land. The ocean protection is a little bit more challenging. You have to now deal with not only just keeping it waterproof, but there's a pressure factor, which makes the enclosures a little more, need to be a bit more substantial. And so the design of them is a bit more complex. So to some degree, sorry? I know somebody had a question there.
No, just keep going.
All right. So in concept, making an animal-borne camera system is not breaking new ground in physics or engineering necessarily. It's taking, you can do it taking elements that are out there and exist and combining them in such a way that is appropriate for animal-borne use. Again, sometimes the marine stuff can be a bit more challenging in terrestrial in a lot of ways. And then you can add on various sensors. Like I mentioned before, there are a variety of sensors. Pressure for marine systems often is very important and useful. A wet switch. For an animal, say like a seal that comes in and out of the water, you don't want to record when they're on the beach. We can use a wet switch to deactivate the system while they're out of the water. Temperature, light levels, accelerometry, is motion essentially. GPS or other satellite tracking, particularly in terrestrial. And one thing that we often do is we've used those sensors not only to record data streams that can be sort of used to complement the video in an analysis, we also tend to use those, or we can use those sensors as triggers. One problem with video is very power hungry. It's orders of magnitude more power consumptive than a lot of the other sensors that are used in animal-borne devices these days. And so trying to extend the use of the life of the system while it's on the animal and also make the video collection sort of more targeted to potentially, trying to only collect video when something interesting is going on. If you've only got so many hours of video to collect, a lot of what animals do is really, really, really boring. That's the reality of collecting animal-borne imaging footage. A lot of time, the animals aren't doing things of terribly great interest. And so we can use the sensors and what we know about the animal's behavior to try and target the video collection. And some of that is something as simple as only recording during certain times of the day or night. So otherwise, we can also potentially use sensors to try and trigger only when we think something interesting is going to be going on. Say, in a very simple sense, depth. So the animal can be observed in shallow water. We know about their behavior there more easily. So only turn the camera on if the animal dives below a certain depth. We've used motion sensors. The camera turns on only when there's a certain level of motion, a certain threshold is met. That, hey, something's happening. The animals, like the cats. Cats sleep a lot. We knew that we get a lot of really boring video if we didn't have some way to try and only record when something was happening. So we used motion. So those kind of sensors can be used not only to add interesting data sets to your data from your deployment, but also to help focus when the video is collected, because it is a very limiting factor. Okay. One thing that's kept things challenging, we have worked with, I think we're right at about 80 species we've worked with over the 30 years or so that Crittercam activity has been going on with National Geographic. And again, everything from blue whales to house cats. The camera design is one of the engineering challenges. The other is attachment. Again, working with a lot of different animals, how you get the system on there is another challenge that keeps our engineering team on their toes as far as how we get these systems on these animals appropriately, because what works on a house cat is not going to work on a white shark. So that's one of the things we have to consider. And then there's a number of things we need to consider when doing an attachment design. It needs to stay on the animal as long as we want it to stay on. Obviously, we don't want to hurt the animal. We also don't, beyond not hurting them, we don't want to impede their natural behavior. Again, that's sort of self-defeating if our behaviors are getting in the way of, or our device is getting in the way of what the animal needs to do. And in most cases, we have an automatic drop-off, so we don't need to capture the animal a second time to get the device back. And we do need to get it back. All our systems record internally, and so we need to get it back to get that video data. And the systems are reusable too, so we can basically just recharge, download, and turn that system around to use it again. We've explored the idea of transmitting video. We've found it's generally just more trouble than it's worth. Things can interfere with the transmission. Transmitting video actually takes a lot of power too, so you are, getting back to that power limitation on the device. Again, generally, so we are recording internally. The device comes off. We recover it using primarily a VHF beacon. But that's part of the design as well. How do you make the system automatically drop off when you want it to drop off? And in the case of, say, marine systems, float to the surface so you can get a radio signal out, because radio signals will not transmit through salt water. So you can't find something that's not at the surface. And I would say, just for anyone considering using animal-borne imaging, there are some considerations. You know, is it, as I don't want to overstate it, but you know, it is challenging to do. So, you know, is it the right tool? You know, it sounds really exciting. It's very cool. It's very sexy to get this video, but is it the right tool to get, or the best tool, considering all the other complications, to answer the research question you have? You know, is there a simpler, cheaper, less risky way to do this? You have to remember, this is an animal instrumentation. You have to have a way to get this device on the animal, and whether that's a capture, which may include, you know, drugging, which is always a concern, or a free-flying sort of deployment like we often do with whales, which is not easy to capture. You know, that still creates, that's a very complicated process. So that's something to consider. You know, do you have the skills, the resources, and is the risk level appropriate in what would it take to get the device on the animal? As kind of was mentioned before about the releases, getting it back. You know, you not only have to get it on that video, you need to get it back so you can get that data to analyze. Part of that is the engineering side of things, the design of the device to get it back. But there's also just a practical logistical concern of getting it back. Even if you have a transmitter on it, you know, are you willing and able to put the effort into it? Because we try to think about where the animal's likely to go and be prepared to, you know, get to the areas where it's likely to be when the device comes off. But things don't always go to plan. The picture on the lower left is an example of one of the many times I have had to get in a small plane, in this case a very small plane, like sort of an open hang glider with a motor on it, or a helicopter, something like that, to do an aerial search to try and relocate a device that came off at some point, you know, not where we were expecting and beyond the range of our radio beacons. And I've had to do aerial searches to try and pick up that signal, you know, and then potentially you go back and then you go back out, you know, on the ground in a boat to pick it up. So, you know, we have a very good recovery rate on our systems, probably somewhere near 95%. We've lost a few, but actually very few. But part of that comes to the fact that our teams do a lot of significant planning ahead of time, trying to make sure that we can get the devices back once they're on. And then sometimes we go to some pretty challenging lengths to get them back once they're out there. So I guess kind of just saying it is not easy to do this. And then there's the analysis. You know, other kinds of sensor data somewhat, or maybe a little easier to analyze. They are numbers associated with a timestamp potentially, and that more easily potentially goes into a statistical analysis package. It's a little harder with video. You know, we've sort of envisioned for years and years and years an automated video analysis system. Now, with AI kind of capabilities creeping along, that, you know, is getting to be potentially more of an option to automate video analysis. But you have to know what you're looking for. And honestly, I'm a little skeptical of it. I mean, you might be able to use automated analysis for very simple features, but there's a lot of detail available in video that I just wouldn't trust an automated software to pick out. So at some point, if it's my research, I'm going to want to look through the video personally. There are some things that help with that. I put some links in there to some software that was developed called Boris and one called Solomon Coder, which they don't automatically analyze it for you, but they allow you to do set up sort of keystrokes that will sort of keep notes for you and note timestamps. So as you play the video, you can set up a keystroke that means, you know, foraging event, and you can do things like a single event, or you can do start and stop and to time events, and that at least gets you sort of a sort of more of a tab delimited columnized data of an event happened, and this is the time point it started at, and you can set up different keystrokes for different events. So that's a little way where you can more, at least somewhat real time, go through your data and get sort of code events and behaviors, and get timestamps associated with them to get durations and sort of timing of things. Unfortunately, to show my age and how long I've been doing this, our old school method was putting a videotape into a video player, connecting that to a TV, and then having a computer with, say, Excel or a Word document open that you were making notes in. And so you played the video, something happened, and you stopped it really quick. But of course, you kind of went too far, because by the time you hit stop, you'd missed the beginning of the event, and so you rewound the video a little bit, started it again so you get the time frame of when it actually started, and then you got back to that, and then you made your notes, and you put the time on the video frame, and you made your notes in, and then you hit play again and watched the next time, at which point you again hit stop and rewound a little bit. It was a lot of work. So things are better these days, but and then, for example, that project where with the domestic cats, we had over 1,000 hours of video. Fortunately, the researchers, I think they did a large recruitment with various students at the university to help them go through all of that. But it is also something to consider that you have a large analysis load once you get this data. But one value of going through it in person is, again, there are things like you didn't even think of, and a number of data and publications have come out of things people found in the video that they weren't even thinking they were going to see, or they didn't even notice the first time through. So there is a lot of potential there, but there is still a great deal of effort involved in extracting it. Let's see. So just for fun, just some more examples of what you can potentially see through the eyes of, so to speak, the eyes of animals. So with that, I'll hope that gives a general overview of animal-borne imaging and our Crittercam program, and I'm happy to answer questions.
All right. Thank you so much, Kyler. That was amazing. Those videos are just incredible. I think we're all really excited by the idea that you can see the world from the perspective of this wildlife and learn about their behavior directly from them, which is such a great idea. Also, this presentation, we had multiple people ask questions that were answered almost immediately after they asked them, which is a rare occurrence in tech tutors. I've never seen so many people just immediately be like, "Oh, okay, that was that was my question." So really good job. I have a few questions to kick us off. So you mentioned that this has been tried on about 80 species so far. What do you think has been the most challenging species that this has been used on so far? And what about that experience made it so challenging? Was it the environment? Was it the behavior of that species? Was it something that the technology wasn't able to do yet?
Yeah, I think most challenging does depend a bit about what aspect of it you're calling challenging. I think one that was surprisingly, it was also not one we expected that was really challenging, was how to get a Crittercam on and keep it on a manatee. Now, we thought that was actually going to be fairly easy. They're big, slow, very docile kind of animals. I mean, they kind of looked to me like they were sort of made out of Play-Doh and not quite finished. And, we just thought this was no big deal, but it took us years of experimentation. Fortunately, we had access to some captive manatees down at Mote Marine Lab in Florida to practice with and do some tests on. So I'm very grateful to the folks down there for working with us on that. But all the things we tried before, and on various other species we thought might work. So we tried suction cups on them, which has worked great with whales and some sea turtle species. Suction cups won't stick reliably to the manatees. Their skin is a little bit too rough. They've got little hairs on them. They are mammals. They do have little hairs on the skin. Cups just weren't reliable. We tried adhesives, glues.
Hey, Kyler, I hate to interrupt.
Oh.
Do you want to turn your camera on?
Oh, is it off? Sorry.
Yeah, sometimes
it
it doesn't come right back on after presentation mode.
Sorry about that. I didn't
okay.
have my little. Oh, there we go.
Continue. Sorry.
Yes. So yes, suction cups did not work. We tried adhesives. We sometimes use adhesive to, particularly on seals. We'll glue systems to the fur on a seal. Adhesives won't stick to manatees either. We tried even like surgical adhesives and things like that. Nothing reliably stuck to them. We tried a couple of different harness rigs, just like webbing, nylon webbing. The first rig we came up with, the captive animals were able to take off. And they removed it in a few minutes, so that didn't work very well. It's tough with them with a harness because they're sort of egg-shaped, so the harness kind of would likely to slide off in one direction or the other. We did end up using just a single belt around their middle, but because that egg shape, we had to make it have an elastic section so it could be snugged a little bit. And this is where the captive animals did us a little bit of a disservice. Is captive animals were okay with that, and we said, "Yeah, we got a solution." We went down to Belize where we were working with wild manatees, and the wild manatees freaked out. They did not like that at all. After one deployment attempt, the researcher turned to me and said, "I have never seen a manatee breach before." And so this manatee nearly leapt full length out of the water trying to get rid of this thing.
And so you got a brand new behavior out of it, though.
Yes,
silver lining.
Not a great one, but yeah. And so we tried, I think, three or four times to deploy on manatees down there, just in case it was one animal that was particularly bothered by it. Yeah, and they got that harness. We had built a weak link into the harness, and this is something we try to be careful of, especially a manatee in these environments where there's, they're in shallow lagoons. There's down trees and logs. We had a weak link in the harness, so if the animal got entangled, it could break itself free and wouldn't drown. They were breaking that weak link. The record was 7 seconds after we let it go. So
very impressive.
Yeah.
On that note, so are there any animals based on challenging experiences like that you would not try to adapt to Crittercam for? I know in the chat during your presentation, Carly was asking if there has been any attempt to use these on primates because of their hands, they could just rip them off.
Exactly. That's something I always kind of thought would be particularly challenging. Animals with opposable digits. We have deployed on macaques in a few different locations, Singapore and Gibraltar. I think fortunately it's in one case we did see one of the animals that in Gibraltar that seemed to be unhappy with his system, and he was fighting with it, and he apparently did eventually take it off, but he took it off and stuffed it in a niche somewhere in the face of the Rock of Gibraltar. We could never get it back. We could hear the radio signal from it, but even with sending Greg on, rappelling down the cliff with a radio receiver, could not relocate it. But some of the other macaques we deployed on there seemed just fine with it. It was one of the funniest things. There was a female actually who had an older youngster, and she was still occasionally nursing it. And we were watching her at one point, actually filming her, and she was sitting there, and she had this camera. It was on a collar, hanging around her neck, and the youngster came up to her and was screeching at her, wanted to nurse, and she just, not even with this, just not even fussing. She just reached up, pulled the camera to the side, and let the youngster nurse. Just hardly even paying attention to it. And that's one of the great things that, that was always one of the fundamental questions that people challenge Greg on about doing this is, you can't put these big things on these animals. They're not going to behave normally. It's going to be affecting their behavior. One of the saving graces of this whole concept is, and Greg started doing some initial tests with captive animals, is the animals generally don't seem to mind the system. Again, if we do our due diligence in making it, attach in a way that doesn't hurt them and doesn't impede them, and they know it's there. But for the most part, they do seem to just get used to it and get on with life pretty quickly.
We had a question in the chat from Graham about this topic. He wanted to know if there has been a lot of research that's gone into the behaviors and if they do change. It sounds like that is something that you've looked into. If I could add on to that question a little bit. So if these cameras are helping you witness behavior in a way that it hasn't been seen before, can you know 100% that it hasn't changed their natural behavior? It seems like they're not really being impacted negatively by it, but I'm just wondering how that's taken into consideration.
Yeah, and that you're right. That is always something we have to be conscious of, and we do believe this is less invasive than a person trying to be there to watch, but it's a factor, and it has been from the beginning. We're kind of always attuned to what we see in the video from the animal's behavior, to see if it looks like they're being disturbed. And again, it's not just we're always. I should have said early on, we as our team at Geographic, we don't just decide to go work on a particular animal project. We are always working with somebody who's an expert on that species already. So we are, I am a wildlife biologist originally, but I'm not an expert on all these species we have worked with. So we're always working with somebody who is the expert. And so we are also relying on them to say, hey, the animal looks uncomfortable. We don't like how the attachment's sitting. They've got the experience hopefully to better judge that, but we are always aware of it. And I guess there always is that potential caveat that there are potentials to compare to when animals have had other devices on them. The only really quantitative study was done with emperor penguins, with Paul Ponganis and Jerry Koyman at Scripps, and they were able to detect using an accelerometer that could detect wing beats, as the penguins were flying in their ocean. And they estimated that the penguins were working about 15% harder when they were wearing the Crittercam than when they weren't. So there was an effect there. Now, at that time, the Crittercams were relatively large compared to the penguin's size. We're always looking to make the technology smaller if we can, because that allows us to work with smaller animals and make it streamlined, less impactful. While there was that detectable effect, the penguins were still feeding. They were still, the dive records looked similar overall, between the animals wearing the cameras and not. The ones we could see in the video, they were feeding. So, they probably were exerting a little bit more energy than otherwise, but it wasn't a complete change in overall behavior pattern.
And that was a perfect lead-in to a question that we got in the registration from, I think this person might be here, Kalamani might be here. If you have a mic, feel free to jump in. But they asked, is this possible to use for small mammals like rats? So what is the smallest animal that this has been adapted for so far?
Yeah. Probably the smallest animal we've done a significant project on is the house cats. Just by pure weight, and some of them were fairly small. We have worked with Galapagos penguins as well, which are again, a good sized house cat, a Galapagos penguin are probably about the same body weight. One thing to think about is there's some of the differences between working with marine animals and terrestrial. Weight is much more of an issue with a terrestrial animal, of course. In the marine environment, you get sort of the water takes away some of that weight factor. Again, you have to deal with drag. So size and weight is always a concern. We always follow the guideline. There's sort of the general rule of thumb for animal-borne devices. No more than 5% of body weight. A lot of times for things like birds, that's ratcheted down to 2%. We've always make sure we're well within those guidelines. And again, we're also just, especially with a big animal or even a biggish animal, I'm concerned about the size, because sometimes the circuit boards don't weigh much. So you could potentially have a system that's within weight limit, but is still just so bulky it potentially would interfere with the animal's behavior. With some terrestrial animals, I've had concerns. With some like low slung animals, badgers and things like that, really short legs. Okay, if we have a camera hanging on a collar, it may be not a weight issue for them, but is it going to basically be hitting them on the feet or dragging on the ground as they walk because they've got such a short stature? So, weight is a first factor always. Size is always a consideration. Most of the weight factor comes into the batteries these days. Again, the electronics are relatively small and light. So most of the time it comes down to batteries. And batteries is how much recording time can you get. So that's often the trade-off. We can often take the same internal guts, the electronics of the system, and just repackage it in a smaller or larger housing depending on the weight limit for a type of animal. And if it needs to be smaller and lighter, that just kind of means you're getting less video because it's going to be a smaller battery. There are some practical limits we run into with really small animals where it just, in theory, you could do this, but yes, you'll have enough battery power for half an hour of video. Is it worth all the effort? Also, things like burrowing animals that are going to go into very tight squeezes. Can you get something on them that, again, it's not going to get them stuck, or they're just not going to shear it off the first time they go through a low ceiling kind of environment. So there are certain practical challenges with every new species.
And you answered a few of our other questions from the Q&A in that. One was about the body weight. So that's really interesting to know. And we might have more on that topic come up, but I'm going to throw to Akiba right now. Akiba, if you want to jump in, it looks like you had some different questions about the cameras themselves.
Okay.
Oh, hello. Okay, I have to find my questions. So it's slightly technical, but and it's like 4 questions in one. But so I think the first one is, do you guys use off-the-shelf cameras or camera modules? So I'll just ask them all at once and just choose which ones you want to answer. So, do you use off-the-shelf cameras that are modified or camera modules? Do you use image processing ICs or FPGAs? What is the approximate battery life? Generally, I know it varies. And is there any kind of open template that the designs are based on, or is it just kind of the Crittercam is just within National Geographic or anything like that? So anyways, yeah, so those are just my questions.
All right, thank you. Yeah, I think part of it, because we've been doing this for quite a while and the technology's changed and the different animals pose different challenges, it's quite a combination of things. There is not one Crittercam, I should say. I guess so. Crittercam is sort of, it's like a family of devices, so to speak. We've had different marine animals, different sizes, different generations. We have used camera-wise, we use things from simple board cameras to machine vision cameras, feeding to some process. Like we're experimenting with one now using a FLIR camera feeding a Jetson for the recording. But often, especially for a lot of the little tiny ones, we've purchased sport cams and spy cams and hacked them because they are really tiny and light, low power, and just they're available and they're relatively easy to use. We design our own controllers. That's often the key thing, is we're aggregating. We don't make the sensor. We buy the sensor. We buy the camera module. We buy the battery packs. And it's the integration and control that often is really the unique engineering, and the packaging, the housing. That's really kind of the core of what we do. And it's taking those different parts and pieces and rearranging them to suit the need of a particular project. And so it varies a lot. And like the first time we've had, I think the cat cams, the ones for the house cats, could record about 4.5 hours total. And that's motion triggered, so you couldn't say how many days that would be or how many hours even total, depending on how active the cat was. But that was sort of with a relatively small battery, where I put a system on Galapagos tortoises where, weight wasn't much of an issue, and there's enough batteries in there to record 120 hours. So it varies widely, and that's partly the fun of this is the diversity of the challenges. It's also one of the tough things is because we keep redesigning it. We're never quite done, and new projects bring in new challenges. And to your final question, right now we've talked on and off about open sourcing the designs and things. It's just kind of something that hasn't been really decided on ever. We don't commercially make these devices. We don't sell them, so we're not protecting that on that basis. In all honesty, part of the whole.
Yeah, I was just curious, by the way.
Yeah.
So is this
part of the holdback on that is just the work it takes to tidy everything up and get it nice and ready to hand off and deal with all the legal stuff. Is we want to take our time and go to the next challenge.
Yeah. Okay. Oh, so thank you. And also, I would say I totally agree that the hardest part is integrating and controlling everything. So, and protecting it all. So that's it.
All right.
Okay. Thanks, Akiva.
Thank you. Ellie has some disturbance in the background, so I'm going to help on this next one. I think our next question was from Rob. Rob, do you want to jump in?
I have about 5.5.
I don't know. Rob's disqualified.
Yeah, no. I have two questions that I'm hoping, because I'm actually working on releasing a low cost, open system that people can muck around with pretty soon. But just throwing back, one of the things with the suction cams, and with the variety of cameras that you've had, did you end up having to design specific release mechanisms for, say, the suction cups versus, the terrestrial collars?
Yeah, we have a lot of the specific mechanics are custom designed. A lot of our releases are driven by what's called an actuator, or I think technically a protractor. They're little, actually, they're like they're used in like fire sprinkler systems and safety systems. They're basically a little metal cylinder that actually has a tiny black powder charge in it, and you electrically activate it, and it pops a piston out very, very hard. It's a short distance, and we use that little piston popping out to drive. We've opened a valve in the suction cups. We've driven a blade to cut zip ties, things like that. They are the nice thing about them. They are safe. Like they're even though there's an explosive charge in them, they are because they're used for safety systems. They are rated non-hazardous. We can actually ship them. There are versions of that kind of technology around that we've even smaller, which we've pursued, which would allow us to do smaller releases, but they are not been certified as non-hazardous, and so we can't we could buy them, but we can't actually take them anywhere. Yeah, that's one of the challenges. They're often made for the military, and so the manufacturers not bothered to do sort of general consumer safety testing. But a lot of the mechanisms around that, to hold that, and to the valve or the cutting system, we'll design that. I know you'd worked on some cutting wire releases, and we've looked at some of those. Haven't really used those. We've used burn wires. It's a variant on that, just sort of a wire that corrodes in seawater. So you put a charge through it when it's on a marine animal, and that wire will corrode in a few minutes and break.
And my other question was, because I've got about 10 little cheap spy cameras as well, and I find a big problem is finding a model that doesn't basically become obsolete within about 10 minutes of buying it.
Yes.
So are you guys struggling with that, or do you have a model or type of camera that you would recommend for, say, a low cost? And I mean, if that's too big a question, I totally get it, but yeah.
Yeah, no, and you're right. That is the downside of not sort of designing our own camera from scratch. The downside of that is, again, the technology advances, and within a year you could make a better one, and you want the better one. So that's somewhat been kind of to the previous question. We've rotated through these cameras as they come up, and then they become obsolete. Or even sometimes the manufacturer changes the design, and it's not something they tell you.
Yeah.
Because the average user doesn't care, but something internally gets changed, and suddenly you can't use it anymore. That has always been sort of a bit of a hobgoblin, this process, and since when we find a good one, we'll buy 100 of them and just have them on the shelf.
See, that's why I can't buy them, because you're buying them all, Kyle. No, thank you. That's awesome. Maybe we'll chat again soon, because when I start to put the release out, it'd be great to get your take on a few things. Thank you so much for this presentation.
You're welcome.
Amazing.
You're welcome, Rob.
All right, Carly, you're up next.
Okay, cool. So yeah, a bunch of I apologize for asking 17 questions. But the ones that I still have, I think, that haven't been answered already are, have you tried this type questions? One is, have you used acoustic recorders in any critter cams, or could they, I mean, I guess in theory, right, it's another sensor, so you could in theory do it, but have you? And then two is, have you tried any sort of wireless transmission for more real-time updates, sending data to a LoRa gateway or something that makes it so that you get some amount of data before the actual instead of waiting for the entire deployment time type thing?
So on the first one, yes, some of our systems have had audio recording. Some of the a lot of the cameras have integrated microphones. They're not great high quality, but they will get us something. We have done, and we actually are working on a new design with a very high quality hydrophone for cetacean work. So yeah, audio is, and you're right, it's another sensor. It depends a bit on how useful that is in the environment and how much effort you want to go into making a high quality microphone, if that is something that's important to the research. For the transmission, like I said, I mentioned we experimented. We did some live transmitting systems about 15 years ago, and I kind of said it was honestly more trouble than it's worth for full event video. We worked with lions over in Kenya, and we had about 5 kilometer transmission range, so not a short range. But the thing is, lions travel more than 5 kilometers most days, and so you had to have a vehicle with your receiving system chasing them around, at a good distance. So we weren't probably disturbing them, but you had to off-road all over the place trying to maintain that range to keep receiving gear. So, and to some degree, is that if you have cameras on multiple animals, do you have multiple vehicles? Because if they go different directions, now you're a bit stuck. And we've decided it seems more useful to put the resources to, let's put out 5 fully independent self-contained systems or more and get lots of data than sort of put all this effort into getting a live stream from one. Now, to your point, we could do something more limited rather than trying to stream all the video. In a very simple way, we always have VHF beacons on our devices, and so we can that's our ultimate recovery device when the system comes off, so we can find it, get it back. Sometimes we use it to keep tabs, at least on the animal. Oh, it's over, to the west of us now. We're not trying to get it, but we're a general idea of where it is. We could do more sophisticated things, like we've experimented with satellite uplinks. But again, that's another device that wants power. What's the value of getting occasional satellite uplinks versus your now reduced recording time because of the power you had to put into the satellite uplink? LoRa offers some potential for very low power, good information transfer, but again, you have to have a LoRa network. So that requires infrastructure at the site. So, but definitely a possibility. And this is kind of again, I came from a wildlife biology background. I'm not an engineer. I've learned a lot working with our engineers in this technology over the years. And the biggest thing I'll say is there is no free lunch. There's a lot of things you can do, but there's almost always a trade-off. So you're usually, and this is true of so many things in life. You can, yes, you can do this, or you can do that, or you can add this other feature, but it's going to cost you something. There's going to be a trade-off for that. As technology advances, sometimes those trade-offs get smaller as the tech gets better. But a lot of times there still are these choices to make. Again, do you want to have satellite uplinks, or do you want to have more hours of recording during a deployment?
Yeah, no, for sure. I was particularly pointing towards LoRa, like LoRa IoT kind of stuff, just because you said like you tried 15 years ago, but you know, the past couple of years have really seen kind of a takeoff in wireless sensor networks and things like that. So yeah, hopefully I hope someone comes up with a solution that I can use. But yeah, thank you for all that.
You're welcome.
All right, and I think I can take back over for now. Thank you, Talia, for stepping in. Shah, are you still here? It looks like you had a couple of questions.
Yeah. Hey, how's it going?
Sure.
I did have a question. I was curious, when Crittercam first started, it was before smartphones, and now we have billions of really low power small cameras on everything. And I was just curious, what do you see the R&D for Crittercam going into the future, like, pointed towards? Like, what are you guys excited about?
Yeah, and one of the challenges we do have, again, as you say, like the cameras on our phones are amazing. So much of that stuff is highly proprietary, and unfortunately we've not yet been able to leverage the Geographic brand even to get Apple or these companies to give us, you know, their secret, you know, sauce for their tech. So that's the thing. That's something that's always frustrating. We know there's better stuff out there, but we can't always get access to it. It's like the release actuators as well, that we could buy them, but they're not certified to travel with and things like that. So those are certain roadblocks. Designing, the potential is there more to design a camera more from scratch than we have in the past. I think it's been a question of the investment of our time. We just a quick, I'm going too long, but TI came out with the DaVinci chip 10 years ago. It was the first HD, like, purpose-built video processing chip. We talked to TI. They said, hey, you can send one of your engineers down for 6 months, and we'll train them how to develop around this chip, and you can make your own cameras from, like, the chip up. And we thought about it, and the problem is 6 months from then, somebody else is going to have another new better chip out. And so there's a little bit of the problem of, if you're going to do it from scratch in-house, there's going to be a large ramp-up time. At the same time, there are companies all over the world innovating and making something that will be better. So there again, it's a little bit of a trade-off there. I'd like to revisit sometime now just an evaluation of what it would take to make our own camera from scratch that would allow us to get around some of the limitations on the components that we can get hold of, the sport cams that we're hacking, that like Rob was talking about. Yeah, it's never quite the perfect thing out there that we can just buy.
All right, awesome. Thank you. And I know we are a little bit past the hour. So Kyler, I think you said you were okay to hang around for a couple minutes afterwards. So we've got one more audience question, and then we've got a closing question from me. Before we get to that, if anyone has to jump off now, thank you for coming along. Make sure you register for next week's episode on using AI to fight wildlife crime. And I think Talia is about to drop the link to that into the chat. And I'll keep going. It looks like our last audience question is from Ale or Al. I'm not sure how to pronounce your name. I'm sorry. Do you want to jump in?
Yeah, really quickly. Thank you so much. It was really interesting. And building on this, is there a way for like National Geographic Explorer to actually loan the Crittercam, or there is a program where people can have access to it? And what would be the best way?
Yes, and that's exactly what it is. So our mission at Geographic, our department, is working with geographic explorers to provide them technology. So that's how we do our projects. We do, and it is unfortunate limitation for others of you out there. We are kind of mandated to support explorers, and we have more requests than we can support. So we are not able to work with just anyone, unfortunately. But yes, if you are a National Geographic explorer, you can reach out to me, and we can talk about, potentially using Crittercams in your research. If you're not a National Geographic explorer, you can always write a grant proposal, become an explorer, and then these resources become available once you're sort of in the family, so to speak. Our resources, Crittercam and other technologies, and loads of other resources that Geographic makes available to explorers just beyond technology, become available.
Thank you.
You're welcome.
You know what? And before I get to my closer, I just noticed we had one more really interesting registration question that I think is going to be a pretty simple answer, but I'd love to know it. Can this be applied to invertebrates like the sea cucumber? Has that ever been attempted?
We have deployed on Humboldt squid. So that's our only invertebrate so far. They are fairly large squid. You might have, I don't know if you caught a glimpse of them, and they're in that montage picture, but they get to be, meter and a half long or so. So they're not calamari size. And even then, that was quite challenging. So I think, potentially something could be put on a sea cucumber. Honestly, I think that would be, I've said a lot of videos boring. I think that would be, unfortunately, really, really boring. Yeah, so again, it's the attachment. Every new animal, even sometimes animals that, like the manatee, seem like they're going to be easy ones, pose a new challenge. But yeah, I mean, if somebody wants to, if you really badly want to put a camera on a sea slug, you might be able to do that.
I'm not an expert, but I feel like that would be easier than some of these other animals because it's not going anywhere very quickly.
Yeah, but it doesn't have any. There's not a neck. There's not a. I don't know.
That's true.
Keeping it attached might be hard.
A good experiment for somebody to try. Maybe that's the next big innovation is Crittercam for the sea cucumber. So it looks like we just have some other basic questions coming through about how people can get in touch with you. I'd like to remind people we have the discussion thread over on Wild Labs. So if you have other questions that are specific to this episode, you can post them there and we'll make sure Kyler gets to see them. But Kyler, is there any way people can reach out to you other than that?
Yeah, people can email me. It's KABERNAT at NGS.org.
Okay, great. And we'll add that to the episode resources as well if anybody wants to reach out. So for my closing question, I don't come from a conservation background. I come from a communications background, so with nonfiction storytelling and such. And so when I hear about things like live streaming animal cams or, other ways to capture animal behavior, the Crittercam, you already answered half of my question, which was going to be about live streaming cams. So, but if there's a more scalable version of this in the future as technology gets more affordable and smaller, and assuming that you could get access to those tools to incorporate them into this, and you were able to, say, put them on larger amounts of animals at a time within a population or something like that. First of all, my first half of this question is, what do you see as the benefits, like the future benefits for research if you're able to do this on a larger scale? And secondly, what do you see as the benefits on the communications and storytelling side? Because I think that would be a really great opportunity to connect people with like the personal lives of these animals on a bigger scale.
Yep. And actually, thank you for bringing that up. That is something I did fail to address in my my presentation, but it is an important thing, and I think that's a large part of the reason why Crittercam has been also given a home, and for so many years at Geographic, is the the data we produce is video, which is accessible to anybody, which again is sort of maybe a strength of it against other kinds of data, which are, look, dots on a map or a graph, a line on a graph, to the average public, that may not be very meaningful or very interesting. But we get video, and that is, as you say, accessible to anybody and everybody. So I kind of look at that as another real strength of animal-borne imaging is it's sort of a dual-purpose tool. I mean, it's creating the video as data for research, but it's also a great resource for education and outreach, which is an important part of all conservation efforts and things like that too, is telling the world about this. And it's a very attractive, it's an accessible and attractive kind of output as well. I literally can take the same video and show it to a kindergarten class at a scientific conference, and everybody has the same reactions. Everybody loves it. And so you don't have to be a scientist or to just enjoy this really cool video. And over the years we have working, and because we're at National Geographic, we also have our pipelines to the public, the TV channels, our website, and social media and stuff like that. We have produced, 70, 80 some different TV shows and shorts, and even more shorts on the websites, where we can just do a little story about the research, and we contextualize it. This is why we were doing. This is what we learned. But we can share that with the public, and it's a great, versus a journal article, which a very limited number of people will ever read. We publish those as well, but the video will allow us to reach a much greater audience and tell people about interesting animals, interesting things, important conservation issues. But I would also say that we are always, Greg drew this line very early on, and I've continued to fully agree and back this, that we will not put cameras on wild animals just to make a television production or any other kind of media product. It just sort of, to us, it's an ethical line that, if you have a captive or trained animal you want to do a cool video for a TV show, we'll help you with that. But on a wild animal, there has to be a sort of research goal, and the media outreach is a benefit, a bonus to that. But yeah, just it's because we are, anytime you're handling an animal like that or interfering with an animal, it's got to be we've got to believe it's sort of ethically justified.
Yeah, I think that's a really great point, that this should be a way to connect people with the importance of the research that's happening versus just connect people with the wildlife with no other point, because I think that is how you get to impact. If people can see that the research is really important, that makes them want to support it, versus, people love things like pandas, but what impact does that really have if you're not actually supporting conservation efforts in some other deeper way? And impact is something that we think about here all the time. How do we make sure that the technology isn't just doing something that's cool and that has a lot of hype, but that ties back into something that conservation really needs? So I think that's a really great point. So what do you see as the next big phase for Crittercam? Like, what do you imagine is the next evolution of it?
There is the potential, I think, as you said, eventually, and it's something there's somewhere in my files, there are like little diagrams and presentations we put together of what you mentioned earlier about like a park with good network connections, where before we were thinking satellite and now what you call it, microwave, but now potentially LoRa, where we could have a lot of instruments out on animals simultaneously getting live feeds and providing a more full real-time understanding of what's going on in that ecosystem with multiple species, with multiple instruments out there. That potential is growing. Again, as was referred to, people are putting up that infrastructure. And when we theorized this a long time ago, it was going to be really expensive and difficult, but that infrastructure is becoming cheaper and more capable. And it serves purposes for like a national park or a protected area. That it has other values for them too. Their security networks or whatever. It supports a lot of functions for them. But then there's potential for us to tie these things in, tie our devices into that, and make it a richer, much more real-time kind of experience. And again, we would, want to start with it first with what's the value for the research and conservation, and sort of the not to use it as, not to diminish it, but the entertainment value, the outreach value would kind of have to be a secondary one, because sometimes you have to make some extra effort or compromises to get it to that level. And it's whether you have the resources to take it there. But, I just want to, honestly, I'd like to grow our, again, I'd like to revisit the idea of kind of designing a camera from scratch on our own. It would give us a little more longevity and flexibility and allow us to build just new generations of Crittercams off that core. Honestly, it's just the real drivers of this is the research community. Again, we respond to them. We are not just coming up with our own ideas for animal projects. We are responding to what people come to us with. So those are the drivers that come, the new challenges. We're always looking to make our systems, lighter, smaller, better, which is just always lighter, smaller works for everything. But then again, the new challenges of some new, like sea cucumber, an attachment for that. How are we going to do that one? Now, that's the thing that kind of keeps the job fresh here a lot for us, is like the crazy challenges of, how the heck are we going to do that one? But it gives us something to really fight down on and work on. It's challenging, but that's very satisfying as well.
Well, we'll all keep an eye out to see what species get added to the 80 species list so far. Maybe that's a good closing question. Is there anywhere we can see the full list of animals this has been tried on? I would be really curious just to scroll through and take a look.
Yeah, I can send you the link. I think I provided a PDF with our publications. That's not all the species, not every species. Not every project results in a publication, realistically. Not every project is highly productive. Some we tried it and it's like, that just didn't really produce what we thought it would. That's not the end. Like I said, that's not the right tool for the question, apparently. I can put together, I think I've got a list of where I can send you and you can provide to the viewers. But also, as I mentioned, you could go to the National Geographic website, nationalgeographic.com, and in the search bar, just type Crittercam. It's all one word. And it's not every species, but I think there's about 36 videos up there, just short web videos that give you some, idea of the diversity and how we, the sort of the excitement, also the fun of doing the adventure of doing some of these projects that we've done over the years.
I think I've watched at least a dozen of those in the past week, and it was very fun. I can confirm to everyone. So go check this out. And with that, I think we're going to wrap the episode. Again, if you have more questions, you can always leave them on Wild Labs or get in touch with Kyler. Make sure you register for next week's episode. That's on using AI to fight wildlife crime. And thank you for coming. Thank you so much, Kyler, for a great presentation. It was a delight to have you here.
Thanks, everyone.